So welcome. So this is the post-coronavirus workshop. So today we're going to talk about the AI and Unreal Engine. So this game project that is already posted inside the workshop archive. You can have the Muffin War start. This is the Unreal project, and we have the AI tutorial slides. So if you look at the game project right now, so if you play it, then you can see if I press the left mouse button, it's going to spawn in a lot of muffins. So in this workshop, we're going to make the muffins attack each other. So what are we going to do is that we're going to create a AI around the muffins that they're going to run around, and then when the muffins detect another muffin, they're going to move to the enemy and attack it. So pretty simple. So let's talk about the three components of the AI. So to create an AI character, so we're going to need three things. So first one's going to be the body. So that's going to be the physical representation of the character. So in this case, so the body portion of the AI is already done. That's already provided from the project. And second is called the soul, which is called entity controlling character, or so this could be the player or the AI itself. And the third one is the brain. So the brain affects the AI making decisions. So we can create this in many different ways. Some use can be done by code, and some by blueprints or by behavior trees. So in today's workshop, we're going to focus on using blueprints and behavior trees. So since we already have the body, all we need is the soul and the brain. But first we need to create a controller, which will be the soul. So what is a controller? So controller is a non-physical actor that can possess a pawn. So possession allows the controller to, you guys said that is a control the pawn itself. So what does control mean in this kind of context? So for a player, if the player pressing the button and having the pawn to do something, so what that controller receives is receives inputs from the player, and then it is going to send inputs to the pawn. So the controller is going to handle the inputs instead and tell the pawn to perform an action. So in this AI's case, the pawn is going to receive information from the controller or the brain. Depends on how the programs decided. So this is kind of like a brain process of this. Let's say the entire behavior tree of this AI. So let's say you can see the player presses the jump button, the controller receives the button press for jump, and then it's going to go through a selection statement. It says controller handles input. If yes, then the controller is going to tell the pawn to jump. The pawn is going to receive the notification to jump, and then pawn is going to perform jumping function. So if you do not let the controller handle the input, then controller is going to send a button press to pawn, and pawn is going to receive the button press, and then the pawn is going to perform jump. So in this case, we're going to let the controller to handle the input. So the way we create an AI controller is by creating a blueprint class. So let's go to the characters /muffin/AI, and then we're going to create a class. We're going to create an AI controller that is based on the AI controller class, and then we're going to name it AIC_muffin. So let's go to the Muffin War, and I'm going to muffins character muffin, and then inside the AI folder. In this folder, we're going to create a new blueprint class, and then we're going to inherit it from AI controller. And then we're going to call it AIC, stands for AI controller _muffin. So if you double click it, it's going to send you, it's very similar to the blueprint itself. And similar to the other blueprints, we're going to have a event begin play and event tick. So next, we're going to tell the muffin how to use the new AI controller. So we're going to navigate to the blueprint of the, we're going to navigate to the blueprint itself. which is in the blueprints folder, and which is called BP muffin. So you can see the project already has the animations and the collisions involved in the on dev events. So you have to worry about it. So it goes to the class defaults, and then you can see this is the POM section. So inside the POM section, we need to set the AI controller class to our own custom AI controller, which is called AIC muffin. So if you go to the controller class, and then we can select the AIC muffin that we created. So save it, and let's go back to the change. And also, since we're going to spawn the muffins, we need to also set the auto process AI to spawn. So this, we're going to make sure that the AI controller muffin will automatically process the blueprint muffin when it's spawned. So let's go back and see that right now it is placed in world, and then we're just going to say spawn. So after that, we're basically pretty much done with the blueprint itself. And so we're going to compile and save it.
Nice.
Hello, can you guys hear me? Okay. Can you guys hear me? If you guys can hear me, please send a chat. So this is the now. Okay. Okay, good. So now we're talking about creating a behavior tree. So the way we create the behavior tree is that we're going to navigate to the muffins AI. We're going to go back to the AI muffin, the AI folder, and we're going to create the behavior tree, and we're going to call it BT underscore muffin. So let's go back to the folder, to the AI folder, and then we're going to create the artificial intelligence advanced asset, and then we're going to create the behavior tree, and then we're going to call it BT underscore muffin, and then we double click it, and so you can see. So the first one, just like a behavior tree. The first being window is going to be, we're going to create multiple nodes. We're going to tell the AI what to do. And second, pretty much a details panel. That way we can like display the properties or change the properties of it. And the third one is a kind of special one for our behavior tree itself. It's called Blackboard. So this Blackboard is going to show the Blackboard keys. We're going to talk a lot more about this later, and their values itself. So the Blackboard will only display when the game is running. So like blueprints, behavior nodes, they're also consist of nodes. So there are 4 types of nodes in behavior trees. So the first 2 we're going to talk about are tasks and composites. So what are tasks and composites? So as the name implies, a task is a node that does something. So this can be something like wait for a couple of seconds, or do like a super amazing combo. So to execute the task, we need to use composites. So a behavior tree consists of many different branches, we'll call the behaviors. And at the root of each branch is a composite. So there are many different types of composites, and they have many different ways of executing the charm nodes. So for example, right here, we have the following sequence. So we can move to the enemy, rotate toward the enemy, and then attack. So the way to do it, the way we can translate it, is we have the roots, which is called as, we have a root, and then we have a sequence, and then so sequence is example of composite. So inside composite, we can connect to move the enemy, rotate the enemy, and attack. And also note the composite is going to, the sequence is going to execute the children from left to right. So you can see from the numbers here, it starts from 0, 1, 2, 3. So let's say, so if any of the sequence of the children fail, then the entire sequence will stop executing. So let's say if the rotate towards enemy fails, then it's not going to run the attack behavior. So the way we create a sequence, we can just drag it out, and just select sequence. So let's say show right here. So just click and drag, and then here we have a sequence. So that's we're going to move, we need to move the pawn. And so the way to create the behavior to move the pawn, which is just create a move to and connect to the sequence. So similar, just drag it out and we could just type for move to. And here's the move to node. And now we can create the rest. So, and the second one is called wait. So very similar, we can just drag it out and type for wait. And then since the default is 5 seconds, we're gonna leave it there. So in order to move the pawn, we need to tell the pawn the specific location that the pawn is going to move to. But however, the move to only accepts the values provided through blackboards. So now we're talking about Blackboard. So Blackboard is kind of an asset whose entire purpose is to hold variables or keys. You can think of it like an AI's memory. So basically, Blackboards are like values in AI. But we're not required to use them. But the Blackboards offer a pretty convenient way to read and store data. So to create one, we need to go back to Content Browser, and we can just create from the artificial intelligence menu and call Blackboard. And then we're going to call it bb_muffin. Let's go back to engine cell. So very similar, add new, write AI and Blackboard. And I'm going to call it Blackboard muffin. And so inside Blackboard editor, so the first one's going to display a list of the keys, and the second one's going to be the details. So now we're going to create a target location key. Since the location is going to be stored in a 3D space, then we need to store it as a vector. So we can just click a new key and select the vector. And then we're going to call it target location. So we're going to create a new key and find a vector. And then I'm going to call it target. So now we need to find a way to generate a random location and store it inside the Blackboard. So to do it, we can use a third type of behavior tree node. It's called a service. I'm going to drink some water here. So service are like very similar to tasks that you can use them to do something. But instead of making the pawn to perform an action, you use a service to perform checks and updates or update the Blackboard. But service is not, they're not like individual nodes itself. Instead, we had to attach, we need to have to attach it to the task or the composite. So you see we have a task called set random location, and then we can, so it is part of the move to node. So the way to do it is we're going to go back to the BT muffin, behavior tree muffin, and click new service. And then we're going to call it a BT service underscore set random location. So let's go back to the behavior tree and new service. So right now we just create a service, but in order to rename it, we need to go back to the folder again and call it app2 rename. And here it is. So this kind of service will only execute when the pawn wants to move. So the way to do this, we need to have to attach it to the move to. The way to do it is to right click and move to function, and then as you can see, we can add service. So let's go back to the muffin, to the behavior tree, and can right click and see there's an add a service, and this is the service that we just added. So right now we have a service that is attached to the move to node. So now we're going to generate a random location. So now we're going to open inside the servers folder. And so to know when the service activates, we can create it's called event receive AI node. So this is going to execute when the service's parents or the node that is attached to activates. There's also an event called event receive activation, but the difference is that the event receive activation AI also provides a control pawn. So, so this is a node we're going to create inside the servers. So here we can event receive activation AI, and then we're going to use the control pawn to get the active location. And then the return value is we're gonna get a random point in the radius. So the one note to talk about it, the get random point in navigatable radius uses the navigation data. We're called nav mesh to determine if a point is navigable. So the project itself already has a nav mesh included. So you can see that this is the nav mesh bounce in volume. So we already have the nav mesh created. So we don't need to create our own nav mesh. So let's go back to the P2 servers, and then we're gonna create a node called, you can just right click and events receive activation AI. And then we're gonna use the control pawn. We're gonna get the control pawn's actor location, get the active location. The target is the actor, and then we're gonna return to get random points in navigable radius. Random point in navigable radius. So we'll make sure the radius of the area is 500. Now we're gonna compile and save. So next, we're going to store the location into the Blackboard. So we can expose a variable, and then we can expose a variable to the behavior tree. So now we're going to create a new Blackboard key that is a type called Blackboard key selector. We're going to call it Blackboard key, and we're going to enable the option called instance editable. So this is going to allow the variable to appear inside when you select the service inside the behavior tree. So let's go back to the Blackboard, create a new key. We can search for the type. Blackboard key selecting. Hold on. Where did I? Maybe it's right. Blackboard key select. Okay, it's right here. Okay, I kind of. Okay, in this type, we're gonna call Blackboard key selector, and then we're gonna call it Blackboard key, and then we'll recompile and save. And so after that, we're going to create these two nodes again. We're going to so this is called set Blackboard value as a vector, and then we're going to have Blackboard key. So we're going to convert this vector as a Blackboard key, and then so we can use it inside the behavior tree. So let's use this connector node called it's called set Blackboard value as vector. So we're going to set Blackboard value as vector, and then since we can just drag it Blackboard key right here, just called get Blackboard key, and then we're just gonna to connect it. Also, we're going to create the output of random equation as the value itself. All right, so now this entire process, just a little bit summary, is that the event receive activation AI is going to execute when its parents, in this case move to, activates. So when it's activated, it's going to get the random location, a random radius, and a random location of the muffin itself, and then so that's within the 500 units of radius, and then we're going to turn that return the random location vector as a Blackboard value, and then we're going to put that, store it inside the Blackboard key. And now, since we're selecting Blackboard, so when we go back to the behavior tree muffin and make sure that we don't have anything selected, and we're going to go to details panel, and we're going to set the Blackboard asset into Blackboard muffin, and then we're going to change it. Again, we're going to select we can finally select the Blackboard called target location. Let me turn off the Steam. existing for a while. So let's go back to the behavior tree muffin. And so we're not going to select everything. And so go to behavior tree, since we can use our own Blackboard muffin. And right now, if you look at the tab to move to, it's going to have a target location as a Blackboard key. So now we'll talk about running the behavior tree. So to run the behavior tree, we need to use the AI controller. So we're going to open the AI controller muffin, and we're going to connect the run behavior tree to event begin play, and make sure that we can set the behavior tree asset to behavior tree muffin. So let's go to the AI controller. Let's go to, we're going to search for run behavior tree, and then make sure the BT asset is BT muffin. So we're going to compile and save. So if you, let's say, so if you play right now, you should see the muffins, they're going to move to their own random location. Do you have any questions, or do you have any troubles, or you just are listening? Please let me know in the chat. Okay, you're just listening right now. Okay, so good. All right, so now we're going to set the kind of like an AI detection, which is called AI perception. So what AI perception does is it's kind of like making the eyes of the AI. So it's going to detect enemies within its range. So the AI perception is part of a component that we can add to the actors. So we're going to go open the AI controller muffin and add the AI perception component. So go back to AI controller muffin, and we can just add AI perception. Now, next we're going to add a sense. Since we want to detect when another muffin moves into the area, like a cone version, we need to call a sight sense. So when you select it, and then we're going to go to the details panel, and we're going to add a new element into this senses configuration. So let's say click perception, and inside of the senses config, we have 0 array elements right now. We can just press plus, and there's 1, and then inside drop down folder, there's just a site config. And now we're going to expand it. So now here are the properties. First is called site radius. This is how far the pawn can see, and the loose site radius is that how far the enemy has to move away from the pawn in order to lose sight of it. And the third one is called the peripheral vision half angle degrees, which is basically how wide the muffin's degree, how wide the pawn's degrees of version. So in this case, we can leave those side radius alone, but now we're going to make it to 45, just so we don't want to make it too sensitive. All right, so by default, the AI perception, they only detect enemies. So enemies, they're basically their actors assigned to a different team. But however, the actors don't have a team by default. So by default, so the actors will be neutral. So the way to do this, we can just expand the detection by affiliation, and we can just add the detect neutrals. So inside the detection by affiliation, we're going to just click by detect neutrals. Okay, so if you click compile right now and go play, and then you can press this is the quotation key. We can display the AI debug screen, and then so this is if you have like a longer keyboard. So so you have to press 4 on the numpad, but not those numbers on top of the letters itself. And you can see the entire debug of the cone of the AI perception. So let's see. show you how to do this right now. So you go press play, and then so you press the quotation mark, and here's the debug screen of AI, and then you press 4 of the press 4. You can see you see this. You can see the muffins of peripheral vision. Okay, okay, you can only see one right now, but well, that's fine. Okay, so now we're going to create the enemy key. So in this step, we're going to move the muffin towards the enemy. So the way to do this, the behavior tree needs to know about the enemy. And then so the way to know about an enemy is that we can just store a reference inside as a Blackboard. So we can open the Blackboard muffin, and we're going to create a key. This is called the enemy, and then and then the type is going to be an object. So let's go to the Blackboard muffin, and we can create a new key, and then we can find the object here. And I'm just call it enemy. So right now we're not able to use the enemy inside move2. So just because the key is an object, but the move to task, they only accept keys of type vector or actor. So now, but we can change it. So we can select the key, and then we can just change the base class into the actor. So you can see so the key type is the object right now. And then we can base class, we can just select it to actor. So now we're going to create a behavior tree for moving towards the enemy. So we're going to disconnect. So we're going to disconnect the previous itself, and then we're going to create a new one. But we're not going to move this. We're not going to delete this, because we're going to like connect all of them together at the end. So we know how to we know how to create these nodes before. So we're going to create a sequence, and it's going to move to the enemy, and it's going to rotate to face Blackboard entry. So this is going to make the upon a lot easier, or it's going to make the upon a lot more sensitive. It's going to rotate itself and face toward the enemy. So let's go back to behavior tree. So one way to do it is to like move this far away, and then the way you can delete this is called hold down the Alt button. And then you can see a highlighted path, and then press left click to delete the node. So now we'll just put them on the side, and then we can just create the move to function. Right now it's the target location, but now we can move it towards the enemy. So we can just switch it right here. And then we're gonna have second nodes called rotate to face Blackboard entry. We can just switch it right here, rotate towards Blackboard entry, and then we need to set the Blackboard key to the enemy. So we're going to talk about sending the enemy keys itself. So we're going to open the AI controller, and then we're going to select the AI perception component. So this is a little bit tricky, but you have to right-click the AI perception in order to add an event. So let me save this and go to AI controller. So the way to create the node is that you need to right-click it and see add events, and then we're going to add an event called onPerception updated. And here's the node. And now we're going to create these 4 nodes. I do have a summation. I can check about it. So let's see. So what it does is that right now it's going to have a Blackboard called enemy. We're going to Blackboard and name called enemy, and we're going to get the object itself, and then we're going to check that. We're going to check the deposit if the enemy is valid or is not. So basically, the entire perception is that we're going to check if the Kona version hits either detected enemy or not. So let's create the node cell. So I can see put down over here, So here's one trick of it. You can hold down the right click to move down towards the event graph. So right now, we just have called Blackboard, get Blackboard as a float. And then we're gonna create another node called make literal name. So we're gonna just right click and search it, make literal name. And then we're gonna just call it enemy. And then we're gonna create a get value as object. So you can see right here, it says the target is Blackboard component. So you can see it says, it's gonna, so this node is gonna come from this node. Got Blackboard, so we're gonna just drag it right here, get black, oh wait, what's it? Get value as object. Okay, so get the value as object. Now we had a, and then we get a value as object for Blackboard, and then we just connect it through the key name. And then we can have is valid. No, right here we just search for is valid. Oh wait. Right here is valid. See right here, and then we're going to connect the return value of the get value as object to input object. So this is the kind of node we see right now. So okay, so one quick tip about like if you want to make blueprint itself. So one way to make the nodes a lot neater, you can just double click at the highlighted path. So you can see this is called redirect node, where I can call it, and you can just change the path of the node itself. So it's going to make it a lot more. It's going to make it a lot nicer, or you can make it worse. Okay, so after this, we're going to create a lot more nodes. So just to check if the AI already detects the enemy. So in this step, we're going to check that if the AI doesn't see the enemy, then it's going to loop through all the objects that the AI has seen, and we're going to change it to the enemy. So one way to do this, so we already have drag down here. We already have the AI perception, and then we're gonna next one's gonna be get currently perceived actors. We just connect here, get perceived actors, and then we're going to after this we're gonna go through a loop. So this only applies if the enemy is not valid. So it's going to connect to for each loop with the break. Loop with break, and it's going to, and then we're going to connect the array to the input of the loop. And we're going to cast it. We're going to loop the body, and then we're going to cast it to BP. And as the object itself, we can just let the array elements of the actors be the object. And then we can use the branch true and false. And then so this node can be a little bit confusing. So the way we do it is call is dead from the BP oven. So we can from the output itself, we're gonna find is dead. So we're gonna find get is dead. So the is dead it's like a Boolean value of the muffin itself. And then we're going to have set value as object. So it's going to be false, set value as object. Okay, so the target is from the Blackboard itself. Okay, set object. Okay, so right now this looks a little bit ugly, so I can just double click it right here. Double click it right here and move it up a little. So this is going to look a lot nicer. And then we're going to connect the key name to the enemy. And I know this is pretty ugly, but you can just move it up a little bit to make it a lot better. And then finally, third step, we're going to connect the output of the cast muffin as the object. So same here. We can just double click it, these two nodes to make it a little bit better. And in the end, we're going to set the value as object. We're going to loop it back. It's going to be oops. Okay, we can loop it back to the break, and then we'll connect to the false cell. And then we can create an action node to make it look better. Okay, this should be a lot better now, a lot better looking. Okay, so in summary of this node, so it's valid, which is right here. So this node is going to check if the enemy key is set. So what it means is that what it means the enemy key is set is that the AI perception is going to search through the actors on the game. And so if it detects the enemy, it's going to set the enemy key. So if it is not set, then it's going to loop over all the currently perceived actors. So the third one is we're going to use the cast to BP muffin. We're going to check if the actor is a muffin. So if the actor is indeed a muffin, and then we can check if the muffin is dead. But if it's not dead, we're going to set the value. We're going to set the muffin as a new enemy, and then we're going to break the loop. So okay. So if the loop is broken, then what it means is that the AI perception has found the enemy. So I hope you guys understand this. So I know it's a lot, but it turns out the logic was pretty simple. So right now, so if you try to click play, you can see the muffin will move to another muffin if you see it. So let's go back and play, and then press create one right here. As you can see, since it detects another muffin, it's going to move to the another muffin's location. All right, we're almost done. Let's see, we're pretty much so we have the last half of the workshop here. So we're gonna make the muffin attack each other. So in order to attack each other, we're gonna create an attacking task. So right now, my parents just come here, so you're gonna hear some noise, but I don't think this is gonna be a huge issue. So we're going to create an attacking task. So just create a new blueprint class. We're going to call it PT task underscore blueprint base. So this is a class we're going to create upon. So let's go to the blueprint cell, blueprint class. Search for PT servers underscore blueprint base. PT task underscore blueprint base, and I'm going to call it BT task underscore attack. We can rename it. So in this new tasks, so we're going to create it when they add, call it event receive execute AI. So this node is going to execute when the behavior tree executes the attack task. So first we need to make the muffin attack. So the blueprint itself already has its attacking variable. So when it sets, the muffins will perform an attack. And to do this, we can add those following nodes. So what it does that, so when the execute AI is going to execute, the control pawn is going to find the BP muffin, and then we're going to set that value is attacking to true. So what to do is just event receive execute AI in the control, and then we're going to cast it to BP underscore muffin. And then also make sure to set the control pawn as the object. And then we're going to set is attacking. So right now we can just check the box is attacking, and then we're gonna connect the output of the BP muffin as the target. Okay. So next, so if you use a task in the current state, it's not going to run it because the behavior tree doesn't know if a task is finished or not. So to do this, we can just add a finished execute node. And then after that, we can click the success. Since we're using a sequence, so this is going to allow the nodes after the attacking task to execute. So this is a final tree, final graph of the attack task. So right now we're going to add a finish execute node. That finish execute node, and then we're going to click on the success. So let's say in conclusion, so what this task basically does, that it's going to execute, this node to execute when behavior tree runs the attack task. And then cast the BP muffin is going to check if the control pawn is called a blueprint muffin. So, and if it is, it's going to set the attack into true, and then it's going to execute. And so after that, it's going to let the other nodes to use it. So we're going to click compile, and then we're going to close it. And now we're going to add this task into the behavior tree. So this is pretty easy. We can just drag it from a sequence, and then we're going to add the BT task attack. So let's go to behavior tree. I'm going to move this a little bit to the left, and just call it tasks. And we already had one called BT task attack. So now and then after that, we're going to add a bit. So this is your choice. We can add a little bit of wait sequence. We can so we can make sure the muffin doesn't constantly attack. But you don't have to do this. So this is basically you can customize it whenever you want to. And then right here, we'll wait time to 2 seconds. Oh, what? 2 seconds. Okay, so if you go back to main editor and play, you can see the muffin is going to attack the enemy. So let's go back and click play. And as you can see, it's going to move to the enemy and it's going to attack it. And boom, the other enemy is going to die. All right. So now we're going to combine all the subtrees together. So the way to combine it is we're going to use selector composite. So first, so similar to sequences, they also execute from left and right. However, the selector will stop whenever the child of the selector succeeds rather than fail. So by using this behavior, we can make sure that this behavior tree only executes one subtree at a time. So let's go open the behavior tree muffin and then create a selector after the root node. So afterwards, we can just connect. So you see we can create a selector right here. And then first we're going to run the attack sequence. And then after that, we're going to create the awaiting sequence or a move to random location sequence. Let's do it right now. Let's go back to where is it? So we don't have the attack sequence. Let's move it to the left, and then I can just hold down Alt to delete it. And then I'm going to create the selector. And I'm going to collect selector to a sequence, and then I'm going to create another sequence to connect the moving to random location. And then just connect these two together. So this setup will only execute one tree at a time. So here's how it runs. So the attack, so here's talk about the attack task. So selector will run the attack subtree first. So if all the tasks succeeded, then the sequence will also succeed. So if the selector will detect this, and it's going to stop executing. So this is going to prevent the roam subtree from running. The second one is called roam tasks. So the selector will attempt to run the attack subject first. So if the enemy is not set or the AI hasn't detected the enemy, then it's going to execute the move to will fail. And so this is going to cause the sequence to fail as well. So since the attack subtree failed, then the selector is going to execute the next child. So let's go back to the main editor and let's play. Let's check it out. All right, so we're going to create multiple pawns together. Okay, defining attack right now. Okay. So I say, why does it attack like? So if you watch the gameplay right now, well, why does the muffin attack the other one immediately? So in a traditional sense of behavior tree, so once the execution starts from the node in every update, so that would mean it's always going to run the tap subtree first and then the Roman subtree second. So that this means that the behavior tree can instantly change the subtrees if the value of enemy changes. But in Unreal, that is not the case. So in Unreal, as the execution picks up from the last executed node. So since the AI perception has not sensed other enemies, then the roam subtree will start running. So the behavior tree now has to wait for the roam subtree to finish before it can reevaluate the attack subtree. So we're going to use, so in order to like switch to other subtrees immediately, we can use the final type of node called decorators. So what are decorators? Similar like services, decorators, they also like attach to tasks or composite. That's so generally similar to services. We can just use decorators to perform checks. So if the result is true, then the decorator will also return true and vice versa. So by using decorator, we can control if the decorator's parents can execute. So decorators also have the ability to abort the subtree. So that means that we can stop the roam subtree immediately when the enemy is set. So in order to use abort, we can use a blackboard decorator. So what it does, it's just going to check if the blackboard key is or isn't set. So we're going to open the behavior tree muffin, and then we're going to right click a sequence of the text subtree, and then we're going to select the add decorator / blackboard. So this will attach a blackboard decorator to the sequence. So you can see right here, so this is how you see the tag sequence. This is going to be a decorator, and inside the blackboard key, and then we're going to set it to enemy. So let's see, and then right click, and then add decorator, and make sure it's set to blackboard. Right now it is set as the target location, but we're going to set it to enemy instead. So what does the enemy decorator set? If it is not set, the decorator will fail, and then we're going to cause entire attacking sequence to fail. So this is going to allow the roam subtree is run. So in order to abort the roaming subtree, if the muffin has seen the enemy, then we're going to have to use the observer abort setting. So the observer aborts will abort the subtree if the selected blackboard key has changed. So we have two types of boards. One is called self and we're lower priority. Self is going to self is going to allow the attack subtree to abort itself when the enemy has become valid. So this can occur even after the enemy dies, before the attack subtree has completed. And the second one is called lower priority. So this is called lower priority subtree to abort when enemy is set. So since roaming subtree is after attack, then the roam subtree itself, it is 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 a lower priority. So we can just change. We can set the observer aborts to both. So we can enable both types. So right here we can see the observer aborts, and then we're going to set it to both. Since we want AI to be a little bit more sensitive. So right now, now the attack subject can immediately goes into roaming if it doesn't see an enemy, and then the roam subject can immediately go to the attack mode if it detects the enemy. So this is the final behavior tree that you should see. As you can see, it has aborts both sections. So here's the summary of all the subtrees. So those are the AI that were at top before. So if you still not understand, you can look at this slides for better understand. So if you try to, so we're pretty much at the end of the workshop right now. So let's say you try to go press play right now. It's going to see the, right now, if it sees the enemy, then it's going to tag it immediately. So you can just say, you can just create like endless amount of them, and then you can see them killing each other. So this is the conclusion of the workshop. So I hope you guys learned a little bit about the AI in Unreal. So talk about the next workshop. So we still don't know who's going to do the next workshop. But I think that if people want to do the workshop, then I'll say it is best to use the online version. So I don't know how many people are inside the workshop room right now, but I say we can also I think the using online workshop is a great option. So I say this is the end of the workshop now. So I just hope you guys to stay safe and don't get infected. Okay.